Okay, just to remind you, this week our surd rules. So square root of AB, so A times B in here, we can split them up into square root of A times the square root of B, or if we've got the square root of A times the square root of B, we can put them underneath the square root and multiply them together. So it can go either way. Similarly here, square root of A divided by square root of A divided by B square rooted equals square root of A over the square root of B. So we can split them up into individuals, or we can put them back together. Sometimes it's useful to go that way, sometimes it's useful to go that way. So, having a look at some of these surds. So simplifying surds, I have a couple of methods. If you know your perfect squares, so you can use your perfect square method. So 18, the perfect square that goes into 18, the biggest one is 9. So we can split 18. 18 is 9 times 2. So we can split it up using our surd rule from previous page. Square root of 9, square root of 2. Square root of 9 is 3, so it's 3 root 2. The other way of doing it is use what I would call is the root prison method. So what we do is we break it down into its prime factors. So 18 is 2 times 9, so 2 is a prime, so we circle it. And 9 is 3 times 3, both of them are prime, so we circle it. And what we do is we put them under the same square root. So 18 is 2 times 3 times 3. Because it's a square root, we need 2 identical. If it was a cube root, we'd need 3 identical. Fourth root, we'd need 4 identical, and so on and so on and so on. So this method works not just for square roots, but for anything. So here, the 2 identical ones, we cross them out, and we get 1 appearing at the front. So here we get 3 root 2. So looking at the next one, here we've got 3 root 2 plus root 50 plus 4 root 5. So the root 50 we can simplify. We can't simplify either of these two. So here, doing the perfect square method, 25 is our perfect square, so 25 times 2 is 50, square root of 25 is 5, so it's 5 root 2, or the root prison method, 2 times 25, circle the 2, 5 times 5, both of them are prime, so 2 times 5 times 5, remember, 2 identical, so identical buddies, cross them out, one of them at the front, so it's 5 root 2. So going back over here, 3 root 2 plus 5 root 2 plus 4 root 5. Well, these two we can add together because they're both root 2's. So 3 root 2 add 5 root 2 is 8 root 2. This one, we haven't got another root 5, so it just stays as 4 root 5. This one, square root 24, 4 times 6. So square root 4 is 2, so it's 2 root 6. Again, root prison method. 24 is 2 times 12, circle the 2. 12 is 2 times 6, circle the 2. 6 is 2 times 3, again circle these two. So it's 2 times 2 times 2 times 3, make up the 24. 2 identical, cross them out, one at the front. Here we're left, neither of these has an identical buddy, so 2 3s are 6, so it's 2 root 6. On this one, 8 times 10, root 8 times root 10, so it's root 80. So again, perfect square, biggest perfect square that goes in is root 16. So 16 times 5 is 80. So root 16 is 4, so it's 4 root 5. Again, we can do it with the root prison. 2 times 40, 2 times 20, 2 times 10, 2 times 5, remembering to circle all the primes. So it's 2 times 2 times 2 times 2 times 5. 2 of them go for it, one of them makes it. 2 of them go for it, one of them makes it. The root 5 doesn't have a buddy, so he stays in the prison. So 2 times 2 is 4, so it's 4 root 5. Last example for this one, if we're multiplying out a bracket, we did double brackets 3 weeks ago. So multiplying the bracket out, we get 9 plus 3 root 2 plus 3 root 2 plus root 2 times root 2. So 9, 3 root 2 add 3 root 2 is 6 root 2. And root 2 times root 2, if you can't remember, multiply them together, we get the square root of 4, which is 2. But a surd times itself gives you the number under the surd. So 2, 9 add 2 is 11, so it's 11 plus 6 root 2.